Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on medical physics from October-November 2021, paper 4, variant 1. I said this is a typical type of question because this type of questions are very common in past papers. So in today's lesson, we will discuss what is meant by sharpness, what is contrast, how we can calculate linear attenuation coefficient. At the end of the video, we will also discuss what are the advantages and disadvantages of CT scan. For part A, we need to state for an X-ray image what is meant by sharpness and what is meant by contrast. We will try to understand what is sharpness with the help of these two images. The first one, I will say this is one and this is the second image of the same bone. Now I want you to look at these two images and try to find out what is the difference between these two images, and then I will explain to you what is sharpness. Pause the video, first try by yourself. Try to understand the difference between these two images. Okay, so let me explain to you now. If you look at the first image, we can see where is the end of the bone. Means the edges of the bones, they are well defined. So this is called sharp image. But if you look at the second image, edges of this bone, they are not well defined. If you don't see where is the end of this bone, it's somewhat like this. So this is not well defined. So simply sharpness means that how well the edges of a structure are defined. So that is sharpness. Now how we can write down our answer? This is how you can write down your answer. Now let's move on to contrast. Contrast simply means that this is the difference in degrees of blackening. If background is too dark, so let me write down here. Let's say background is too dark. We can say background is too dark. We can simply say image is too bright. So in this case, the image has good contrast. So we will say image has good contrast. Because the background is too dark and image is too bright, it means that is good contrast. Now look at these two images. Let's say this one is image 1 and this one is the second image. Take some time and try to find out which one has good contrast. I mean, which one has better contrast, 1 or 2. Take some time, first try by yourself. You need to look at background and image brightness. I hope that you will say second has good contrast, means it has better contrast as compared with 1. Because if you look at the 1, especially if I look at this part, you can see this is dark, this part is dark, and the background is also dark. So it means there is not very good contrast. But if you look at this image, even you look at this part, for example, this is not as dark as this one. It is brighter as compared with 1, and the background is the same, is too dark. So it means this one has better contrast. So we can say it has good contrast. So the difference in degree of blackening in this case is higher, in this case is lower. So this one has good contrast. This is how you can write down your answer. So simply you need to write down difference in degrees of blackening. So you will get 1 mark. And for sharpness, if you have written ease with which the edges of structure can be determined, or you can say how well the edges of structure are defined, you will get 1 mark. So this has 1 mark, this is B mark, and this is also B mark. I hope that it is clear to you now what is sharpness and what is contrast. Very common question. Most of the time in past papers you will see they will ask you what is sharpness, what is contrast, and this is how you can define. For part B, it is given to us X-ray beam passes through a thickness of 2.3 centimeters of soft body tissue. Intensity of emerging beam is 12% of the intensity of incident beam. We need to calculate linear attenuation coefficient of the soft body tissue. And also we need to write down the unit of mu, linear attenuation coefficient. We also need to write down the unit of this one. Now let's try to understand this one with one very simple diagram. What is given to us? So this one, you can imagine that this is soft body tissue. So this one is soft tissue. I will simply say soft tissue. Incident X-rays. So we can say these are incident X-rays, and the intensity of incident X-ray we can say is I naught. We can also write down incident X-rays, incident X-rays, and intensity of emerging X-rays, or you can say transmitted X-rays. Let's say the intensity is I. So these are transmitted X-rays, means after passing through soft body tissue, transmitted X-rays. The value of X, the thickness of this soft tissue is given, that is X, and X is equal to 2.3 centimeters. Now the question is asking us to calculate the value of mu. First thing we need to understand how we can write down the equation for this one. In this case, I transmitted, so I will say I transmitted in this case is equal to I naught, mean this is I incident, times e to the power of negative mu x. Now simply we need to plug in values. I transmitted is given to us. This is 12% of I incident. So we can write down this is 12% of I naught, or simply you can also write down here I is equal to 0.12 of I naught. So in this case, I transmitted is 0.12 of I naught, and here we have I naught e to the power of negative mu x. Now you can see I naught we have on both sides, so simply we can cancel. So I naught with I naught. So we left with 0.12, and this is equal to e to the power of negative mu x. Now if we take ln on both sides, we can say ln of 0.12, this is equal to ln of e to the power of negative mu x. This is negative mu x. We can write on in this form ln of e, but ln of e is equal to 1. So this one is equal to 1. So simply we left with negative mu x. We have ln of 0.12 negative 2.3. This is the value of x, and here we have mu. So from here we can find out value of mu. The value of mu in this case will be equal to 0.92. Now let's try to understand how we can determine the unit of mu. For that purpose, we will look at unit of power of E. Power of E has no unit. Power of E, it has no unit. It doesn't make sense that the power of E has some unit. So the power of E has no unit. Now we need to understand e to the power of negative mu x. So if the unit of x is centimeter, so can you guess the unit of mu? So unit of mu, you will simply say that this one has to be per centimeter. So the centimeter per centimeter, they will cancel. So the power of E will have no unit. So that's the point you need to understand. And this is also required for paper 5. Sometimes you need to determine the unit. So if you understand that power of E has no unit, you can use this way and you can find the unit of any unknown quantity. So in this case, we will say the unit of mu is per centimeter, because the unit of x is centimeter. So our final answer in this case, this will be 0.92, and the unit is per centimeter. For example, if x was in meters, then the unit of mu will be per meter. So this point you need to understand that power of E has no unit. This question has 3 marks. So the first mark is if you have written this equation, you will get C mark. And the second mark is also C mark. If you have plug in values of I transmitted, you will get the second mark. And the third mark is answer mark. If you have got the right answer with the right unit, you will get the third mark. For part C, question is asking us to suggest an advantage and disadvantage of CT scanning compared with single X-ray imaging for diagnosis. First of all, we will talk about advantage, then we will discuss disadvantage. Advantage of CT scan is that we can get three-dimensional image, and image can be rotated and it can be viewed from different angles. So image can be rotated. But in case of X-rays, we only get 2D image. So that is advantage of CT scan over X-rays. Now let's try to understand what is disadvantage. In case of X-rays, X-rays pass through the body of the patient only one time. So we don't repeat process. I will simply say one time. And the process is not repeated. So we can say not repeated. But in case of CT scan, you can see, first of all, we have X-ray source here, meaning CT scan, we also use X-rays. So here we use X-ray. And they pass through the body of the patient. On other side, we have detectors. They will detect, and 2D image will be produced with the help of this. And then we rotate this X-ray source, and again we repeat the same process. We make another two-dimensional image, and then we move this to the next position and we repeat the process again. So you can see in this case the process is repeated many times, and then we combine two-dimensional images to form three-dimensional image. So as the process is repeated many times, a lot of X-rays pass through the body of the patient. So simply we can say a lot of X-rays. That in this case, less X-rays pass through the body of patient. So that is disadvantage. As more radiations pass through the body of the patient in CT scan, that is not good for patient tissues. So our cells, that is not good for cells and tissues. So that is disadvantage. Now let's try to write down the answer, how we can write down the answer. So this is simply how you can write down the answer. You can say CT scan can produce three-dimensional image. And for disadvantage, we can say that patient is exposed to radiation for a long time. But in case of X-rays, patient is exposed to radiation for short time. So we can also write down exposed to radiations for short time in case of X-rays. But in case of CT scan, the patient is exposed to X-ray radiation for a long time. So this is disadvantage of X-rays. And this question has 2 marks. The first mark you will get if you have mentioned it produces three-dimensional image, you will get 1 mark. And if you have mentioned about longer time exposure in CT scan, you will get the second mark. And this is also B mark.